All right, so this is our last section, and the whole section is solving equations of which you're really, really good at. So when we look at this section, you're going to come away with another type of equation that you're solving. Big deal. The only curveball in the section comes at the end, and it's just, again, it's a matter of fundamentals. Can you square a binomial? How do we square binomials? What do we do in here? Square the first, twice the product, square the last, the 9 words. If you can do that, nothing that I show you today will be complicated. If you can't square a binomial, everything blows up in the second part when things get a little bit tough. But all of the solving equations is no different than what you've done in the past. It's the same process. The basic or the fundamental process is to isolate your radical first. Or if you have a fractional exponent, isolate the base with the fractional exponent first. And since you don't really want to work with the radicals or the exponents, right now we're just talking radicals. Step number 2, eliminate the radical by raising both sides to the power of the index. So if you have a cube root, cube both sides. If you have a square root, square both sides. The key here is that both sides have to be squared or cubed, not each individual term. And I'll emphasize that a lot more later. But remember, in general, when we talk about both sides, when I say BS, that's what I mean. I mean both sides, not each individual term. Okay? And when you don't do it as a side, when you square individual terms, that's where it blows up. Jennifer, you good? Isolate radical, get rid of the radical, solve. You're back to an Algebra 1 problem or Algebra 2 problem now. I can't stress this enough. Check your answers. Checking your answers is the insurance here. How many of you have had a house that you lived in burned to the ground? Okay, not anybody. I've had 2 in my neighborhood, which is really unusual, but I've had 2 in my neighborhood. Everybody in my neighborhood, though, has the insurance in case you did burn your house to the ground, and I'm sure all of you have insurance for that. The insurance isn't because your house is going to burn to the ground. But if something weird happened, and it did catch fire and you lost everything, your insurance is to protect you. Checking your answers here is to protect you. I assure you that you will find answers that you've done all the algebra correct, but the answer doesn't work. What do we call an answer like that? Extraneous. Very good. Extraneous. So there are extraneous answers in this section, and I will hammer you on it. And you're not going to see an extraneous solution for a while. It'll be towards the end of the lesson. So let's take a look at this example right here. This is asking you to solve for x. It's got a radical in it. So what you want to do is you want to isolate the radical. Already done. We want to now say, let's raise both sides to the power of 2. When you square a square root, you get the radicand. You get 5x minus 9. What do you get when you square the other side? 121. You know what some people are going to get? Nope. 22. It's a property. You multiply these. You know the property. 11 squared 121. Now what kind of a problem? Algebra 1. Easy. What do we do? Add 9. And divide by 5. x equals 26 appears to be our answer. You want to take time, plug it back in. 5 times 26 minus 9 is equal to 11. I know that some of you won't do it. You'll say, I'm not going to do that. I don't really care if it's extraneous. I'll just lose the coins. That's certainly your choice. Okay? That's going to give you the square root of 130 minus 9, which is going to be the square root of 121. And the square root of 121 is? It's just 11. It is not plus or minus. The square root of 121 is 11. The only time you get plus or minus is if you have x squared equals a number, or x to the fourth equals a number, and you square a fourth root both sides. But the square root of 121 is 11. This is a good answer. You can check in your calculator. Okay, here's a check on a calculator. This is just the screen from a graphing calculator. The square root of 5 times 26 minus 9 is 11. It checks. However, the test is no calculator completely. So there's no part of the test that you can use a calculator on. So it's better for you to practice without using a calculator. Every time you practice with the calculator, it slows you down on the test. Any questions on this example? Easy when it's already isolated.
Question. On the test, will there be adding negatives? Like, on these, will there be negatives?
Give me an example of what you mean.
Like, I don't know, like, would you ever have to add negatives and positives together on these?
Well, I have to add 9 over here. Is that what you mean? Like, if I had plus 9, I would do minus 9. Is that what you mean?
Like, would you ever get, like, negative 121 plus 9?
Sure. You can do that, right? I hope. You need to be able to add and subtract negatives. You need to be able to add and subtract fractions. If you remember back in January, I said, Algebra 2 isn't the barrier for a lot of people in here. It's arithmetic. Can't add and subtract fractions, can't multiply and divide fractions, can't add and subtract negatives, can't multiply and divide negatives. These are the death blow for a lot of us. Okay, so again, here's another, what do? Isolate the radical. Make it say radical equals, here's the twist. If there's 2 radicals, you got a couple of options on what you could do here. If there's 2 radicals, you could combine them. If you could get them to be the same index with the same radicand, you combine them. That would be terrific. Not going to happen very often. If there's only the 2 radicals, you could make it say radical equals radical, and then you'd square both sides and the radicals would disappear. That would be great. Again, that's going to happen, but there's also going to be times when there's radical on one side and radical plus or minus something on the other. When that happens, and we'll do that in a few minutes, that's where it gets really tricky. You have to do square both sides, isolate the remaining radicals, square both sides again. It's kind of time consuming. So when you have multiple radicals, you just got to be careful. This page is just a restatement of what I've already said. So this is the book notes that we've included for you, and we'll post this online so you can see all this. See if you can solve for x in this one. It's just like the problem we did for an example a moment ago. So I'm not trying to trick you here. It's very similar. Okay, so what did you get for x? 75? Really? Wow. Okay, so what do we do first on this one? Square both sides. So x plus 6 equals 18. 81. Okay, be careful. Make sure you're squaring, not doubling. and x equals 75. Easy, right? Square root of 75 plus 6 is root 81, which is 9. Here's a calculator check over here. Square root of 75 plus 6 is 9. Everybody good with that? It's like tossing softballs. Easy. A little bit more complicated now. We have a radical, but it's not isolated. So see if you can isolate this. Okay, so what are we getting for x on this one? Negative 30? Negative 3.
Yeah.
Yeah, with attitude.
Wow.
I'm just saying. All right, so what do we do first? Subtract the 1 to isolate that radical. How do you get rid of the radical?
Cube it.
Cube both sides. So we're going to get x minus 5 is equal to negative 8. You're doing good with those. How do we get rid of the 5? Add it. So the cube root of negative 3 minus 5 plus 1 should equal negative 1. This is the cube root of negative 8 plus 1 equals negative 1. Negative 2 plus 1 equals negative 1, and in fact it does. Good answer.
Is it wrong if you don't subtract the 1 for the first step when you do x minus 5 plus 1 equals negative 1?
Well,
Is that worth it?
x minus 5 plus 1 equals negative 1 will not work.
I thought negative.
You may have gotten negative 3, but you would have gotten lucky to get that. You must have had a lot of things working your way, because when you cube each of these individually. Well, you have to cube both sides. And I don't see how the coincidence worked out, but it just was a coincidence. If I change that to a 2, it no longer is going to work. Okay? So you have to isolate the radical first, then get rid of the radical. If you don't, you might get lucky, but I wouldn't bank on that luck. Because the stars just aligned on this planet for you. Okay? So here's the calculator check for you. And again, it does check. Any questions so far? Okay, 2 things to remember. If it's in radical form, this is what we've been doing right here. The nth root of a, raise it to the index power, and you'll get the radicand. That's what we've been doing. You're going to look at a couple of examples here when you have a fractional power. You're going to raise to the reciprocal power here, here. You're just going to flip the power and raise both sides to the reciprocal power, but it's both sides to the n over m power, and then you'll get the base by itself. All right, I'll give you another option. If you don't like working with the exponents, you're going to have to tell me you want another option, and that'll be fine. We can look at it a different way. But the examples we're going to look at right now is going to look like this. 7x to the 3/5 equals 56. Again, if you're not checking your answers, you're setting yourself up to get points taken away strictly by not checking your answers. So first thing we do here, number 1, isolate the term with the power, the base to the power. That means the 7 has to go. How does it get eliminated? Divide both sides by 7. So x to the 3/5 power is equal to 8. Now they're going to give it to you and make everything nice and perfect for you, as will I on the test. No calculator, right? So it's not going to come out to be a 7 here, or a 10. It's going to be an 8 or a 27 for this problem. How do I get rid of the power of 3 over 5? Not multiply. You don't want to multiply. Raise to the power of. Now, when you raise to the power of, you are going to multiply exponents. But I don't want you to say multiply by 5 over 3, because that 5 over 3 should go in front if that were the case. When you multiply your powers here, what do we end up with on the left?
1.
X. How can I rewrite 8?
20.
Okay, we could do that. 2 cubed. If I just want to rewrite the 8 as 2 cubed, almost all the time, and for sure on the test, 3 times 5 over 3, they're going to cancel. And you're going to end up with x equals 2 to the 5th, better known as 32. You need help with what? If you don't know them, you can always tree it. And what I'm telling you is when you're here, Nina, this 8, I assure you, you can tree it and it'll be a perfect something that will cancel with that 3. Okay? So when you do 7 times 32 to the 3/5 power, 7 times 32 to the 3/5 power, you should get 56. How can I rewrite the 32? 2 to the 5th to the 3/5. The 5s are going to cross cancel, and you're going to get 7 times 2 to the 3rd. And what's 2 to the 3rd? 8. That means this is a good answer. X does equal 32. Tonight, if you're doing it on the homework and you want to check with your calculator, you can plug it in like that, but it's not going to help you the day of the test. And if you're practicing with the calculator, the day of the test might not work out too well for you time-wise. Is anyone not understanding the powers and would rather see a different way to do this problem? If you don't like the powers, there's other ways to do the problem. But it's up to you. I like working with the powers on one like this, but totally up to you. Is there anyone not wanting to see?
Can you show the different way?
I can, but not unless you're uncomfortable with powers. It's silly to do something that's a little complicated to outrun 3 over 5.
Okay. Do you think the other way is?
You want to see it? I would never use the other way. That's why I'm not showing it unless someone's asking.
Right.
So when you get to this line and you have x to the 3/5 is equal to 8. Okay, if it's confusing you, gosh, I just don't know how to, I don't get this power reciprocal crap or whatever. We switch to the 5th root of x, and then whether or not you want to go to the 3rd, or I'll put the 3 outside, is equal to 8. But if that 3 on the outside is going to bother you, it might be easier to say, I'm going to do the 5th root of x to the 3rd equals 8. Either of those lines will get you to where you want to be. If you use the first line with the 3 on the outside right here, then you're going to cube root both sides next. But here, we're going to get rid of the radical, just like on the problems earlier. How do I get rid of a 5th root? You raise to the 5th power. So if we say this is the 5th root of x to the 3rd equals 2 to the 3rd, when I raise both sides to the power of 5, I'm going to get x to the 3rd is equal to 2 to the 15. How do you get rid of the power of 3 on x? Cube root. So if we cube root now, cube root, we get x equals 15 divided by 3 is 2 to the 5th, which is 32. I don't personally do that, but it is certainly something worth exploring if it's of interest to you. Again, checking your answer is going to prove to be pretty valuable.
You said that there were integers 3 on the side of the
Then you would cube root first, and you'd get a 2 equals the 5th root of x. The cube root of 8 is 2. The cube root of something cubed is whatever you were cubing. Either way is fine with me. Any other questions on this one? So let's see what happens if we get a binomial to this power. See if you can take this one all the way through to x equals. See if you can take this through to x equals by yourself. All right, so again, this one's already isolated. The 3x plus 4 to the 2/3 is by itself. So what I've suggested is to go ahead and raise both sides to the 3/2 power. On the left-hand side, you get 3x plus the 4 all by itself. How could I rewrite 16? You could do 2 to the 4th. What else could you do? 4 squared. So if we do 4 squared to the 3/2 power, and we multiply our powers, what do we get? 4 to what power? 4 to the 3rd. What is 4 to the 3rd? 64. Now you're back to Algebra 1. What do we do? Subtract 4 and divide by 3. X equals 20. Here's a calculator check for you. 3 times 20 plus 4 to the 2/3 power, in fact, does give us 16.
I'm confused on how you get 4 squared and then 3/2, and then how you get to the next, how do you get 4 cubed? Like, I don't get that.
Right here to here,
Yeah.
this is a property. A to the m raised to the n power. You see how this looks like this?
Yeah.
What does this property tell us to do with our exponents?
Multiply everything.
Multiply m and n, and you get a to the mn power. What's 2 times 3/2 give you?
6/2.
Better known as
3. Oh, okay.
right? That's exactly right. 6/2 reduces to 3. 2/1 times 3/2, 6/2. But what I'm telling you, this is the honest truth for this book. They're not going to make it so it doesn't cross-cancel right here. So if you think about this, you're multiplying 2/1 times 3/2. These guys are going to just cross-cancel. You seeing that?
Yeah.
So they're serving it up for you. They're really trying to make it, they want you to understand how to get rid of the powers, but they're not going to give you something that's ugly on the right-hand side here. Okay? Okay, so now we have a situation where you have a radical, but you don't, when you isolate the radical, you don't just get one term on the other side. You get a binomial in this case on the other side. So here's where that getting rid of the radical by raising to a power becomes really important that you understand that you do this to both sides. Okay? So when you're doing this, you really have to be checking your answers. You really have to check your answers on this because this is where you end up with a quadratic and you get multiple solutions here. So I have radical isolated, so I want to take both sides and square them. The left side is easy. Ellie, what will I get on the left side?
X minus 6.
X minus 6. The whole reason why we're squaring is to get rid of that radical gone. Okay, perfect. See ya. Okay, Elise, what do you get on the right-hand side?
X squared minus 16x plus 64.
X squared minus 16x plus 64. This is the 9 words. Square the first. Twice the product. Square the last. Even still, I know people are going to give me x squared plus 64. Square the first, square the last, the heck with twice the product. You have to be able to square a binomial in here. Now we're back to chapter 4. What do we do?
Add
Yeah.
6.
Add 6 and I'm just trying to cut time here.
Oh, try. Or
I gotta get rid of both of these and make it 0. Add 6 and
plus 16x both sides.
no, because then you're bringing stuff to the left. I want this to be a 0.
Oh, okay.
Add 6
Minus
and
x.
minus x. So the x squared, we want it to be positive. When I subtract x, I get minus 17x. When I add 6, I get 70. And if you need to do 2 lines, do 2 lines, but I think you're going to get tired of that quickly, especially as you see these things get more complicated. What do we do now? Your favorite F word. Okay, you're here, you're a quadratic equal to 0. We love this. So we're going to factor that to x minus 7, x minus 10 is equal to 0. What does x equal? 7
And 10.
and 10. It is imperative that you check your answers. And you need to check them in the original problem, which is the x minus 6 equals x minus 8, square root of x minus 6. So we're going to do the square root of 7 minus 6 is equal to 7 minus 8. The square root of 1 is equal to negative 1. Is that true or false? That is false. So 7 is an extraneous solution. If we check the 10, the square root of 10 minus 6 is equal to 10 minus 8. The square root of 4 is equal to 2. Is that true or false?
True.
True. Your answer has to be x equals 10. And that's it. If you write 10 and 7, it's not going to work.
What if we, or will we ever get like 2 extraneous answers?
Sure. Then you would say,
No answer?
well, you're an algebra
Or
teacher.
no real answer?
No, no solution. No solution. And sometimes that happens. That just means there's no in common solution. There's no value of x that's going to make this true. Try B. See if you can solve B by yourself here. Okay, so x minus 2 and root x plus 10. So we're going to square both sides. Square both sides. Did you do this, Natalie? Did you square the x minus 2? What'd you get? Minus 4x plus 4. Very good. Equals x plus 10. Yeah? Sarah, what'd you do next? So x squared minus 5x minus 6, perfect, equals 0, right? Which is what we wanted. Were you able to factor it? Did you? What'd you get?
X minus 6.
Very good. A lot of people are mixing in the 2 and the 3 there for factors. X minus 3, x plus 2 doesn't work. It's x minus 6, x plus 1. So x would equal 6 or negative 1. 6 or negative 1. When we plug in the 6, you have 6 minus 2 is equal to the square root of 6 plus 10. Or 4 is equal to the square root of 16. Is that true or false? That's true. So the 6 is a keeper. When we plug in the negative 1, you'd have negative 1 minus 2 is equal to the square root of negative 1 plus 10. And negative 3 equals root 9. Is that true or false? That's false. So we have to throw away the negative 1 and we keep the 6. All I want to see is 6. Don't make it a mystery. Don't tell me, go write me a note and say, ooh, I got 2 answers, but negative 1 was extraneous. I don't want notes. I don't need any notes. Just tell me x equals 6 is our solution. Careful there. Everybody good so far? It's really nice when you just have to do a binomial like this. All good. The problem is, and you'll have there's 4 of these problems from the homework tonight on the test. I think they're the last 4. And one of those 4 is looking like this problem. And this problem is very challenging because of the 2 radicals. If the 2 wasn't there, if we covered up the 2, and you had radical equals radical, it would be all good. We can't simplify either radicand, so we can't get the same radicand, so we can't combine them.
Can you change 2 to a 4 under a radical?
You could, but it doesn't help you. In order to add and subtract radicals, they have to be the same radicand. So there's nothing you can do.
If you change it to a 4 under the radical, then wouldn't it be like, it would be like a radical equals a radical, and then...
No, it would be a radical plus a radical equals a radical. So
Okay.
again, you can't combine them because different radicands. If we were multiplying, sure, you could put it back under 1 and then that would be fine.
I think I would confuse that with addition.
But not necessary either way. This is all we can do. So when this happens, you want to get one of your radicals by itself, the other radical you want on the other side. The last thing you want is radical plus radical on the same side. So if you have 2 on the same side, put one of them on the other side. Make it be radical equals, like the slide said earlier. So the same process will still hold true for us. We're going to take both sides and we're going to square it. Now again, on the right-hand side, easy. Malin, what do I get on the right?
You get 100. Or no, you get 10 minus 3x.
10 minus 3x. The whole deal is to get rid of the radical. It's gone. On the right-hand side, easy. On the left-hand side, you have to recognize that this is still a binomial. First term is root x plus 6. Second term is 2. Binomial squared. Okay? The first term is root x plus 6. When you square the first, what do you get, Nina? X plus 6. That was easy. This isn't so bad. When you square the last term, Spencer, what do we get when we square the last term? Plus 4. Plus 4. This isn't so bad. The problem is when you do the middle, it's twice the product. So it's twice the radical times 2, which is going to be plus 4 times radical x plus 6. Square the first, easy. Square the last, easy. Twice the product, not so pretty. Square the first. The first term is root x plus 6. You get x plus 6. Twice the product. Root times 2 is 2 radicals, right? Double that would be 4 radicals. And then square the last would be plus 4. Square the first, twice the product, square the last. The twice the product is the tricky part. Radical times 2, and then double that would be 4 radicals. So now we have this big messy thing with a radical with x underneath. We can clean up the left-hand side a little bit. We have some like terms with the 6 and the 4. X plus 10 plus 4 times the square root of x plus 6 is equal to 10 minus 3x. What should we do now? What are we heading to do? You're right, subtract 10 will get me there. What am I ultimately trying to do? Not equal to 0 yet. Not equal to 0 yet. What do you think, Hannah?
Isolate the
Isolate the radical. Okay? And minusing 10 would do that. I'm going to subtract x and I'm going to subtract 10. And I'll show you that just so you can see it. You're going to get 4 radical x plus 6 on the left. The 10s nicely disappear, and we get a negative 4x on the right. This problem proves to be pretty easy. When we divide by 4 to isolate the radical, we end up with negative x. So now I have the radical isolated again. I have to do it twice. I did the first radical, the root 10 minus 3x, and squared both sides. Then I isolated the x plus 6 radical. What do I do to solve for x plus 6? Square them again. So we take and square both sides again. On the left, what do we get? X plus 6. Be careful on the right. What do you get? What do we get on the right?
x squared.
X squared. A negative times a negative is a positive. A negative squared is a positive. Now what? I'm going to go over it. All right. You could, but then you'll have a negative x squared. Yeah, you want a 0, but you don't want to bring this over.
Subtract x plus 6.
Yeah. Some people say, well, it's less work to subtract the x squared. No, it's not. You have to rewrite the whole line. So no matter what you do, you're doing the same amount of writing. 0 equals x squared minus x minus 6. How's it factor? X what? So x is going to equal 3 and negative 2. Now, you've got to check those all the way back to the beginning. You have to go back and check these all the way back at the top. When you check the 3, you're going to get the square root of 3 plus 6 plus 2 is equal to the square root of 10 minus 3 times 3. This is root 9 plus 2, and this is root 10 minus 6. Sorry, 10 minus 9. So we're going to get 3 plus 2 is equal to the square root of 9. What is the deal? Square root of 1. 5 is equal to 1. True or false? Usually false. So that means 3 is not going to work. So we go back to the answers, this 3 is not going to work. It's extraneous. If we check the -2, so the square root of -2 plus 6 plus 2 is equal to the square root of 10 minus 3 times -2. That's going to give you the square root of 4 plus 2 equals the square root of 16. That's true. So our only solution, x equals -2, that's our only keeper. You have to have both solutions in your work. You have to get all the way down to 3 and -2. You have to check the 3 and throw it away and just keep the -2. This is our only solution. These problems get difficult. They are challenging. If you can't do them, you're going to start with missing one problem on the exam. That's not good. Give this one a try. See how you do with this one. Give this one a try. See how we do. This is fun. Very similar to the one we just tried. Square each side, okay? So when you square the left, that was the good side, right? What'd you get? X plus 6. Did you get the other side done okay, do you think?
I got 11 plus 6.
That's square the first, good job.
Plus 9 square root x. 11. Sorry. Plus 9, 11 minus x.
Okay, then what? I'll give you the plus 9 at the end. Okay? This is a -3, right?
Yeah.
-3 times the radical will be -3 radicals. Don't square it, double it. Twice -3 radicals is, if you double -3, what do you get? -6 times the radical. So in the middle it'll be -6 times the square root of 11 minus x. I think you squared the product and only squared the -3 part. Does that seem logical? Okay. So now if we were to combine like terms, x plus 6, what can I combine on this side, Carlton? Give me something I can combine on the right. Which two things?
Canceling out the left is that.
I just want to combine, not get rid of yet. I just
The 11, the 6, and then 9.
not the 6, but the 9.
Oh.
Because the 6 is attached to the radical. You see that?
Yeah.
So 11 and 9 gives you 20 minus x minus 6 radical 11 minus x. So which way, what are we going to do? We're going to get rid of some stuff. What do you think we should get rid of? Caitlin, what can I get rid of? Subtract the 20 and add the x. So that's going to give me 2x. And then when I subtract the 20, it'll be a minus 14, right? Equals -6 radical 11 minus x. Is everybody with me so far? Now, this is a trick that I would recommend. You do whatever you want. We need to isolate the radical. So I'm going to go 2x minus 14 and divide that -6 and leaves me the radical 11 minus x. I'm not going to worry about dividing or simplifying that left-hand side because my goal is to get the radical by itself. Once the radical is isolated, what do? Square on both sides. Christo, on the right-hand side, when I square it, what do we get? That's the whole reason why we squared 11 minus x. Jennifer, what happens when you square the bottom here? Just the bottom. You get 36. Now the negative's gone, but we have a 36. On the top, we have a binomial that we need to square. So we square the first, we multiply these together and double it, minus 56x, and we square the 14, and we're going to get 196. Again, I know that you could have simplified earlier. And if you want to do that, that's fine. You could have factored out a 2 from the 2x and the 14 and cross-canceled it with the 6. It's not going to matter in the long run. Now that 36 is sitting there on the bottom. What do I do with it? Huh?
Multiply the 11 minus x.
Actually, you want to multiply both sides
Oh, yeah.
by the 36. And these are going to cancel, leaving me with 4x squared minus 56x plus 196 is equal to 396 minus 36x.
Then can you combine like terms?
Well, you can, but you need to actually set it equal to 0. We want the right-hand side to be 0 to keep my x squared positive and bring everybody else to the left, combining those like terms. When you add 36x to the negative 56, you're going to get 4x squared minus 20x. When you subtract 396 from 196, you get minus 200. This is all arithmetic. What do I do now? You could do it, your favorite F word, I get it, but before we factor, divide everybody by 4 on both sides. So if we do both sides and divide everybody by 4, you're going to be left with x squared minus 5x minus, looks like 50 equals 0. X squared minus 5x minus 50 equals 0. How does it factor? X minus 10 and x plus 5 equals 0. So what does x equal?
10, negative.
Negative 5. So we have two potential answers, 10 and negative 5. If you check the 10, you're going to get 10 plus 6, square root of 10 plus 6. That's going to give you a 4. Square root of 11 minus 10 minus 3 equals negative 2. They don't check. So the 10 doesn't check. If you check the negative 5, the square root of negative 5 plus 6 is 1. The square root of 11 minus a minus 5 minus 3, also 1. X equals negative 5 checks. It's the only answer that's going to work for us. So the 10 doesn't check, so we will keep the negative 5 only. These problems are time consuming, and if you don't practice them and practice them well, you start off minus points on this test. It's not the way to go. Does anyone see any questions on this mess? It's all about process here. Now the last thing I want to show you is an example of an application with the radicals. Velocity of a free-falling object on any body, whether it's the Earth, the Moon, whatever, the velocity at any given time would equal the square root of 2gh, where v is the velocity at any time, g is the acceleration due to gravity in meters per second squared, and h is the distance the object has fallen. So the gravity depends where you are. Here on Earth, gravity 9.81 meters per second squared. On the Moon, it's much smaller. On Mars, it's in between the Moon and the Earth. So here's your formula. Velocity equals root 2gh. What should I put in for velocity for this problem? 30. So we're going to start with 30 for the velocity equals the square root of 2. What's gravity? 9.81. We're here on Earth. And h is what you're looking for. In other words, how far up were you? Where did they drop you from that made you have a velocity of 30 meters per second? How do we solve this? What do you think? Right. Square both sides. 900 is equal to 19.62h. 900 equals 19.62h. How do you find h? Divide by 19.62. What do you get? 45.872. Okay, so that's how high, 45.87 meters, 4.5 stories up, you jump, you'll hit the ground at 30 meters per second. That's how fast it is. So this is a typical application problem. On the test, however, you won't have nasty numbers like this. Everything comes out clean on the test. Every exponent, every radical, they are all nice, pretty numbers. If you need a formula like this, I give it to you. Yeah, don't memorize velocity. This is like from the Big Bang Theory. You don't need to have that memorized. Sheldon, he would know that, but the rest of us mortals don't need to know that. Okay? This is your assignment. Please take care with these equations. It's worth 16 points on your test tomorrow, on your test on Thursday. I think there's 6 graphs. If you haven't got the graphs, the parent graphs dialed in, make sure you get them dialed in. I think there's 6 good guys and bad guys problems.